Hey gang, hope you're loving life today. So in this video, we're going to be going over angles and triangles, focusing on how they relate to each other within a triangle and especially in right triangles. So let's start with this one here. Cosine x equals 3/5. Which of the following is equal to 4/5? All right, so quick refresher, cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. And tangent is sine over cosine or opposite over adjacent because the hypotenuses would cancel. And with that right, we get SOHCAHTOA to remind ourselves. All right, so in this question, we have this angle x whose cosine has a 3/5 ratio. So let's draw out a triangle, all right? Let's call this angle up here, or this point x, this z, and this y. So this angle is x. So that means this adjacent side is 3, and this is going to be 5. And let's find this one here, right, with Pythagorean theorem. It'll be 3 squared plus b squared equals 5 squared. So that's 9 plus b squared equals 25. So b squared equals 16. So b equals 4. Okay. So sine x. Let's look at our answer choices to give us more information, right? Tangent x would be 3 over, or 4 over 3. So it's not that. Sine 90 minus x, 90 plus x, 90 minus x. So what is going on with that, right? What is this angle? So let's go back to this question and think about the relationship the angles have to each other. This is the right angle, right? So the three angles together add up to 180. So we could say x plus y plus z equal 180. But z is 90. So x plus y plus 90 equals 180. And that means x plus y equals 90. And that always holds true for right triangles. The two angles that aren't the right angle add up to 90. So that means that this is going to be y equals 90 minus x. So that's 90 minus x. So that's where we're getting this 90 minus x part, right? That's this angle right here. This 90 plus x, that doesn't really help us with anything. That's not an angle in this triangle, so we're just going to cross that off. Well, if you had a unit circle, you could work it out to find 90 plus x, and that would get us in the left quadrant. It'd be a negative value, but we don't have to worry about that. 90 minus x, though, is going to be, so cosine 90 minus x is going to be what? 4 over 5. Oh, well, that is our answer. Now, sine 90 minus x, just for good work, right? That would be opposite over hypotenuse, which is 3/5. And that makes sense, right? The sine of the other angle is equal to the cosine of the first angle, right? They have that relationship going. So you can also say sine x equals cosine 90 minus x, or vice versa, right? You could say cosine x equals sine 90 minus x. Perfect. Great. And now let's go to the next one. Triangle ABC is similar to triangle JKL. A measure of angle A equals 52. What is measure of angle K plus measure of angle L? All right, so you might be wondering how we're going to find this when we know nothing about triangle JKL except that it's similar to triangle ABC. It's not too bad, actually. So let's draw this hypothetical triangle ABC, right? Let's say this is A, this is B, this is C, so this is 52. And then let's draw hypothetical JKL. corresponding parts, right? You can imagine they're identical except in size, right? So JKL. So this is also going to be 52. So then we can do K plus L plus J equals J equals 180, and we can substitute for 52. So K plus L plus 52 equals 180. And then let's subtract 52. Subtract 52. So K plus L equals 128. Okay. And we can't find what K and L are individually with the information they gave us, but we don't need to find it, right? This tells us, this gives us what we need, right? We just need to find K plus L, and it is D. Okay, great. And now we will go to the next question. What is measure of angle BAD plus measure of angle ABD plus measure of angle CDB in the triangle below? So this touches on one of my favorite facts, and that is that if you have a right triangle in which, and then you divide that right triangle by dividing the right angle and crossing to the hypotenuse and making a right angle there, all three triangles are similar to each other. So ABC, the big one, is similar to, let's focus on this one here first, right? It'll be A, because angle A is the same as angle A. And then angle B was a 90-degree angle, so we're going to go with the 90-degree angle next, D. And that leaves us with angle B here in place of angle C. So it's going to be ADB. And now in this triangle, right, we're going to do the same thing. Let's start with the big triangle ABC is similar to, okay, so angle, let's start with angle C, right? Angle C is going to be equal to angle C, so that's corresponding, C to C. And then angle B is the right angle, and angle D is again the right angle, so it's going to be D. And then that means angle A is now replaced by this part of angle B, so it's going to be B. And through transitive property, right, you can say ADB is similar to BDC. And this is helpful knowing there's other questions that are more complicated than this one, where you have to find side lengths based off of the rules of proportions. And we'll do those soon. But for now, we're just focused on the angles. So let's find, we want to find BAD, which is just angle A. So that's going to be, let's use that 90 rule, right? Where this angle plus this angle have to equal 90. So it's going to be 39 plus A equals 90. So A equals 51. That means this angle here is 39. That means this angle here is 51. So let's find what we're looking for. BAD is 51. ABD is 39. And CDB is 90. So if you look at what happens there, right, is 51 plus 39 plus 90 equals 180. So that'll be your answer. And that's the degrees of a triangle, which makes sense, right? Because we had two angles of a triangle, and then this angle here, right, which is the same as this angle here. So it's really like we found this triangle here, right? And you could have done that if you had thought about it that way from the beginning, it would also work. And if you think about it another way, let me know in the comments. I'm always interested in new methods and techniques. And if you have questions on this question or on any of the questions before, or you want more questions in this type, let me know. I'd be happy to make more questions like this and more videos for you. And if you just have any general comments or feedback, leave them in the comments. And if you like this video, please like and subscribe. And I'll talk to you all later. Thanks.